Hello guys, today we start to study chapter 7, Waves. This chapter contains 17 sections divided into 4 parts. We will learn about wave motion and description, sound waves, electromagnetic waves, and wave behavior and light. A wave can be simply defined as a periodical disturbance that moves away from the source and carries energy as it goes. Waves can be categorized into two types: mechanical waves and electromagnetic waves. Mechanical waves involve particle motion and it can travel through matter, such as sound waves, water waves, and so on. Electromagnetic waves consist of varying electric and magnetic fields and can travel by self through vacuum and matter, such as radio waves, light, X-rays, and so on. According to the direction of wave motion, mechanical waves can be classified into transverse waves and longitudinal waves. For transverse waves, particles move perpendicular to the wave direction. Transverse waves can travel through solid, such as rope waves. For longitudinal waves, particles move parallel to the wave direction. Longitudinal waves can travel through fluids and solids, such as sound waves. Water waves are a combination of both transverse and longitudinal waves. To quantitatively describe waves, we need to define some quantities such as wavelength, wave frequency, wave speed, wave period, and wave amplitude. Wavelength, usually denoted by lambda, can be simply defined as the distance from crest to crest or trough to trough of a wave. Wave frequency F is the number of crests that pass a given point each second. The unit of wave frequency is Hertz, or per second. The wave speed, that is defined as the rate at which each crest moves, is then equal to the product of wavelength and frequency, i.e., wave speed v equal wavelength lambda times frequency f. The wave period is the time needed for a wave to pass a given point, and it can be calculated from the reciprocal of the frequency, i.e., t, the period t equal 1 over frequency f. The maximum displacement of particle from the normal position is called the wave amplitude. The greater the amplitude is, the stronger the wave is. The wave will have more energy if amplitude is greater. For example, find the wave speed on the period. If 10 waves, each 2 meters long, pass a point by every second. From the wave speed formula, we have v equal lambda times f. Substituting 2 meters as the wavelength lambda and 10 waves per second as frequency f, we can find the wave speed equal to 2 times 10 equal to 20 meters per second. The wave period is the reciprocal of the frequency f, equal to 1 over 10 equal to 0.1 second. A wave that remains in constant position is called standing or stationary wave. It usually occurs when reflected wave interact with forward moving waves. For examples, standing waves in stream. Sound waves are longitudinal waves with speed of 343 meters per second in sea level air, and can be faster in liquids and solids. Decibel or dB is the unit of the sound intensity. Sound with frequency less than 20 Hz is called inferior sound. Sound with frequency greater than 20,000 Hz is called ultrasound. In hospital, there are ultrasound machine. They can detect stomach, the body, inside of the body. A human ear is most sensitive to the sound with frequency between 3,000 and 4,000 Hz. The frequency of human speech sound is usually less than 1,000 Hz and in average about 145 Hz for men and 230 Hz for women. The apparent change of frequency or wavelength due to the motion of wave source related to receiver or listener is called Doppler effect or Doppler shift. The wave decreases frequency or redshift if the wave source moves away from the receiver, and increases frequency or blue shift if the wave source moves towards the receiver. Doppler effect also occurs in light waves. The observation that lights from galaxies all redshift indicates that the universe is expanding, originated from a Big Bang. Sound produced by vibrating objects such as strings, vocal cords, membranes, etc. is called music sound. Music sound has two types of tones, the fundamental tones and the overtones. Fundamental tones are produced by vibrating the object as a whole. The overtones are produced by vibrating the object in segments. When an object is vibrated in its natural frequency, we call the phenomena as resonance. From what we learned in Chapter 6, Electricity and Magnetism, electric field originates from charges, while magnetic field originates from moving charges. Faraday discovered the magnetic field when it varies produces electric field. Later on, Maxwell discovered that electric field, when it varies, produces magnetic field. In other words, varying electric and magnetic fields produce and link each other, so that propagate through space and form waves called electromagnetic waves. Therefore, electromagnetic waves consist of varying electric and magnetic fields, travel by itself at the speed of light 3 times 10 to 8 meters per second in the vacuum. In electromagnetic waves, the electric field and magnetic fields are perpendicular to each other. Both are also perpendicular to the wave direction. Hertz first discovered electromagnetic waves in labs. That's about 20 years later, after theoretical prediction by Maxwell. Electromagnetic waves can carry not only energy but also information. Electromagnetic waves have a wide range of frequency and thus have a number of types in its spectra, including radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. Increasing order of frequency or decreasing order of wavelengths. Radio refers to transmitting and receiving of radio waves or signals. There are two types of modulation in radio. The amplitude modulation, shortened by AM, modulates or changes the radio wave amplitude to carry signals. The frequency modulation, shortened by FM, modulates or changes the radio wave frequency to carry signals. Radar, shortened from radio detection and ranging, is a device that uses ultra-high frequency radio waves to detect distant objects such as ships, airplanes, and so on. Light usually refers to visible light. It is a type of electromagnetic waves with high frequency or short wavelengths. Because of short wavelengths, light apparently travels in a straight line in a uniform medium. As this, we usually represent light as rays. This is the first part of this chapter. We will continue next time. Thank you.